So if you're going to have any trouble at all with section 5.3, it's going to be with these types of problems. So make sure that you take the time to write this down and write it down really well and ask any questions you have. This tells us to suppose that the sine of an angle S is equal to 3/5 and the cosine of an angle T is equal to negative 12/13. And we would like both S and T to be in quadrant 2. We would like to find the value of the cosine of S plus T, given just that information. So here's how you start. You take what you're trying to find and you expand it out using the identity that we learned today. That will give you 4 values to substitute in. You know 2 of the 4. You will have to go off to the side and find the remaining 2. And I'll show you the different ways to do that. So we're going to start with cosine of S plus T. And using our identity, we'll expand that to cosine of S times cosine of T minus sine of S times sine of T. Okay? So that's going to give you 4 things to multiply together. 1, 2, 3, 4. I gave you 2 of those things. I gave you that sine was 3/5. So we'll put that in there. Sine of S is 3/5. And I told you that cosine of T was negative 12/13. That leaves us wondering, what is the value of cosine of S and sine of T? Once we know those 2 things, we can finish this problem. So we're going to come off to the side.
This isn't radians.
It doesn't matter, actually, because you don't ever know what the angles are, so we don't know if they're in degrees or radians. All we're trying to find are the values of the trig functions of the angle, so the actual angle doesn't matter. So let's take a minute, let's come off to the side, and let's talk about the angle S. What's the one thing we know about S? We know that its sine is 3/5. What do we want to know about S? The cosine. So one way, when we're dealing with angle S, to do that would be to use the identity sine squared plus cosine squared equals what?
1.
So then we could just plug in the one we know and solve for the one we don't know. So let's see. We know sine was 3/5, so we'll plug that in here. That would be 9/25, correct? Right here, 9/25. Okay, so if I subtract 9/25 from both sides, that leaves me with the cosine squared of S equals, what's 1 minus 9/25? 16/25. Then you square root both sides, and we see that the cosine of S is plus or minus 4/5. And we just have to assign the positive or negative based on the quadrant. In quadrant 2, cosine is negative, and we know it's in quadrant 2 because we were told that. So this becomes negative 4/5. Now you have to stop and go do the same thing for T so that you can find sine of T. So it's just a really long, tedious problem, but it's not anything we haven't done before. I do want to remind you that you don't have to use identities right here if I want. I could, instead of using identities again, I could just draw a triangle. I could go to quadrant 2, and I could draw a triangle for angle T. And we know, what do we know about T? We know that cosine is negative 12/13, which is x over r. And I could use the Pythagorean theorem to find this, the y value. Do you guys remember this from the definitions? So you're allowed to choose your method, whereas last unit you weren't. You had to use identities. Okay, what does this have to be? Does anybody know? Do you remember the Pythagorean triple that makes that true? No? Well, then we'll do it together. We know that x squared plus y squared equals r squared. We know that x squared is 144 plus y squared equals 13 squared, so 169. So y squared is 25. So it looks like y is plus or minus 5. In quadrant 2, that's going to be positive 5, correct? Okay, so that's where we are. And I just need to know the sign of that. And remember that sine is opposite over hypotenuse or y over r. So in this case, sine would be 5/13. And that's how you find the two missing ones. And you can do triangles or identities, it doesn't matter. Then you simply come back, you multiply everything together, add it up, and get a fractional answer. So we have positive 48/65 minus 15/65, which gives us, I cannot subtract. 33, okay, 33/65. And the unfortunate thing about this is you can't check that one in your calculator. Not really. Did that make sense, or is there some part you're kind of unclear on? Okay, so one more time from the top. I ask you to find the cosine of s plus t or s minus t, depending. You use your formula to expand it out, then you substitute in the two you're given, and you come off to the side and you try to find the two that you weren't given. You can use identities or definitions and triangles to do that. Then you plug those two back in, tally it all up, and there's your answer. Okay, so I know you thought you were finished verifying, but you were wrong. There will also be verifying at the end of this unit test. So, we would like to verify the following equation. We know that the secant of 3π/2 minus x has to equal the negative cosecant of x. Which side should we start on? Left. I think the left, yeah, definitely. Okay, well here's the bad thing. We don't have a formula for the secant of two things subtracted. We only have the formula for the cosine of two things subtracted. So the first thing we're going to do is convert this secant to a cosine. So that's 1 over the cosine of 3π/2 minus x. What identity did I use there? What's that called? That's the reciprocal identity, right? Now that I'm there, I can use the difference identity for cosine to expand that denominator out. I don't know what else to do with it. So let's try that. So now we have 1 over cosine of 3π/2 times the cosine of x plus the sine of 3π/2 times the sine of x. Oh, that 1 is not centered. I have to fix it. No. All right, that's
3π/2 is a quadrangle.
We're doing the plus sign.
It is, yeah, you're right. I did. Okay, so 3π/2 is a quadrangle. It's the same as how many degrees? 270? So we know some stuff about that. We know that it's the ordered pair 0, -1. So we can fill in the cosine and sine from that. So cosine of 3π/2 is 0. So that really gives me 1 over 0 times cosine of x, which is 0, plus the sine of 3π/2 is -1, so plus a negative sine of x. So really that's just 1 over the negative sine of x, right? This whole piece goes to 0. So you have 1 over negative sine of x. And now if I use a reciprocal identity again, that really 1 over sine of x is cosecant, so really that's just negative cosecant of x. So I actually think that the verifying for the second part of this chapter is actually a little easier than the first part.
I like this better than what we're doing at the beginning of the section.
Oh, good.
It's easier, and I don't know why I
I think it's easier too. I think it's you're less likely to make mistakes. So, all right, any questions? All right, that wraps up section 5.3.